Hi students, in this video we are going to study total internal reflection or TIR. Now before going to this topic, let us see what happens when a ray of light travels from a denser medium to a rarer medium and rarer medium to a denser medium. Now imagine there is a rarer medium and there is a denser medium, and ray of light travels from the rarer medium and incidents on the denser medium. Now what happens? The speed of light will decrease and it will bend towards the normal. Angle of incidence, angle of refraction. Same way, what happens when ray of light travels from a denser medium to a rarer medium? When the ray of light travels from a denser medium to a rarer medium, what happens? The speed will increase and the ray will move away from the normal. This angle of incidence and this angle of refraction. Now, imagine a condition in which light is traveling from a denser medium to a rarer medium. As when it is traveling from a denser to rarer, a part of light will be refracted and part of light will be reflected back to the medium itself. And this reflection is known by name internal reflection. When light travels from a denser to rarer medium, a part of light is getting reflected back to the medium itself and is known by the name internal reflection. Now what if we attain a condition in which the entire light ray is reflected back to the medium without any refraction to the rarer medium? This particular condition is known by the name total internal reflection. So imagine an object is kept at this particular point O. Now if a ray of light is incident from this object normally to the surface, what happens? There won't be any deviation or there won't be any refraction or bending of ray, and the ray will continue to move in the same path. But when the ray incident on the medium at an angle or obliquely, definitely it will get refracted. A part of light will get refracted and a part of light will get reflected. Okay. Now imagine a condition in which the angle of incidence is increasing. Okay. Now as the angle of incidence from the denser to rarer is increasing, accordingly angle of refraction will also increase. Now again, if I increase the angle of incidence, then angle of refraction will again keep on increasing, and there reaches a point or there reaches an angle of incidence for which the refracted ray will be, or refracted angle will be 90 degree, and the ray will pass through the surface of the medium. Yes, there is a particular angle of incidence for which the refracted ray will just graze or pass through the surface of the medium, and angle of refraction will be 90 degree. Any further increase in angle of incidence, there won't be any refraction, but the ray will be completely reflected back to the medium. And this phenomena is what we call total internal reflection or TIR. The phenomena in which a ray of light traveling at an angle of incidence greater than critical angle. What is critical angle? I will say greater than critical angle is totally reflected back to the denser medium. When it travels from a denser medium to a rarer medium is known by the name TIR or total internal reflection. The phenomena by which a ray of light when travels from a denser medium to a rarer medium incident at the interface at an angle greater than critical angle of incidence greater than critical angle, then the ray will be completely reflected back to the medium, denser medium itself, and this phenomenon is known as critical angle. So the question is, what is critical angle? I told you, as the angle of incidence increases, there reaches an angle of incidence, or there reaches a point where the refracted angle or refracted ray or the refracted angle will be equal to 90 degree. So the angle of incidence at which angle of diffraction is 90 degree, or the refracted ray passes through the surface of the medium, is known as a critical angle denoted by the letter IC. The angle of incidence for which angle of refraction is 90 degree is known as the critical angle, and if again we are increasing the angle of incidence above the critical angle, definitely the entire ray will be reflected back to the denser medium without any refraction to the rarer medium. So, there are two conditions which must be satisfied for the ray of light to undergo TIR, total internal reflection. That is, first one, the light should travel from denser medium to a rarer medium, and second one, the angle of incidence should be greater than critical angle. Only if these two conditions are satisfied, then TIR will happen. Now the question is, what the same phenomena can take place when the light travels from a rarer to a denser medium? I told you, when light travels from a rarer medium to a denser medium, what happens? It is bending towards the normal. So this phenomena can't take place, right? Only if the light is traveling from a denser medium to a rarer medium in which angle of incidence is greater than the critical angle, then TIR can happen. Now we are going to write the relation between critical angle and refractive index of the medium. Relation between critical angle and refractive index. So we know that Snell's law is given by sin I by sin R is equal to mu to 1. In our case, the light ray is traveling from the denser medium to the rarer medium. So this is taken as, it's actually medium 2, and this is actually, usually we take this as medium 1. But in our case, light is traveling from medium 2 to medium 1. And for TIR to take place, the condition is for angle of refraction to be 90 degree. Angle of incidence must be equal to the critical angle IC. So in that case, the above equation can be written as sin IC by sin R, that is 90 degree, equal to mu 1 2. Why? Because light is traveling from denser to rarer medium, we are writing as mu 1 2. Now sin 90 is what? Sin 90 is 1. So the above equation can be written as sin IC is equal to mu 1 2. But the standard way of writing refractive index is mu 2 1. And we know, according to principle of reversibility, mu 2 1 is equal to 1 by mu 1 2. So the above equation can be written as mu 2 1 is equal to 1 by sin IC. This is the relation between refractive index and critical angle. Mu is equal to inverse of sin IC. Okay. Next, we are going to see the famous application of TIR, that is Mirage. You know what is Mirage, isn't it? It is an optical illusion. It is just a imaginary thing which a traveler who is traveling in very hot region like desert sees. Now, Mirage, it is an optical illusion observed by an observer in desert or coal tar. Coal tar means very hot region of coal tar road, due to which the traveler sees a shimmering pond of water some distance ahead of him, surrounded by trees. The person will be seeing a pond of water with trees, inverted image of trees with it. And this is just an optical illusion. So, what to say? We're thinking of your brain. Now, what causes mirage? Now, you know, if it is very hot, okay, very hot, the surface of the earth will be very hot. The air which is closer to the surface of the earth will be also very hot. And if you take a region and divide the air into different layers, you can see that this layer that is very close to the earth, the air will be hotter when compared to the one above it. And this layer will be much more hotter when compared to the layer above it, etc., etc., etc. And when air is hot, density will be less, isn't it? Which means this layer, we are dividing the density into D1, D2, D3, etc. Then we can say D1 is less than D2, which is less than D3, etc. Which means this layer can be compared as a rarer medium when compared to the layers above it. So this is a rarer medium, this will be a denser medium. When we compare these two, this will be a rarer medium and this will be a denser medium. Now what creates mirage? Now imagine there is a tree, okay, there is a tree and the light from the tree is traveling through the different layers of air, as I told you. Now as the light is coming down, what happens? Ray of light is coming down, what happens? Light is traveling from a denser medium to a rarer medium, comparatively rarer medium. Now what happens when light travels from a denser to rarer medium? It bends away from the normal. So at each layer, the incident ray will be bending away from the normal, and as a result, the angle of incidence, this angle will be comparatively less than this angle. Means as it is coming down to each layer, angle of incidence will keep on increasing, and somewhat near to the surface of the earth, when the ray hits that surface, what happens? The angle of incidence will be greater than angle of critical angle, which means as a ray of light is coming down, what happens? Undergoing multiple refraction, and in each case, when it is passing through each layer, angle of incidence increases, and at a particular point, it reaches a particular point where the angle of incidence becomes greater than angle of the critical angle of that particular of the air, and as a result, the ray will be completely reflected. And the observer who is very far away from the tree, for him light travels in a straight line, so he will see an inverted image of the tree somewhat like this. And because of the illusion that we see inverted images in water or in shadows, but shadow means no color, mostly we see inverted images in water, our mind gets the illusion that there is a pond near to the tree. And this is what we call a mirage. I'll explain once more. The surface of the earth, air layers, is comparatively hotter than the one above it. As a result, density will be comparatively less for the layers of air near to the surface of the earth. And when a ray of light from a very distant object passes through such layers of air, what happens? Each time it is passing through each layer, it bends away from the normal, and critical angle angle of incidence to each layer keeps on increasing, and when it reaches a particular layer, it is found that angle of incidence will be greater than the critical angle, and hence the entire ray will be reflected back to the denser medium, and the person who is standing very far away will see a ray of light coming in a straight path, and he will get an inverted image, and because of his illusion, he will assume that there is water near that tree region. And this phenomenon is what we call mirage. Thank you.